Uh, let's get started here. Hi, my name is Kiran. I'm a performance dev lead on UI platform in Microsoft. So what I have here today is some of the guidance which me and my team have put together. And these guidance will really help you write those performant and awesome XAML apps. Right? So before getting into the guts of the system, what I would really like to do is spend some time talking about performance in general, right? I promise I won't spend more than 2 slides on this because you would have heard these slides many times in many of the performance talks. So the basic question which all the time has been asked is how does one think about performance when he builds an application? Very easy to think, right? The basic thing which you need to understand is there are 3 basic pillars for any application's performance when you think about the performance of an application. So these pillars are fast, fluid, and efficiency. So no one likes the applications which are really slow to start up. No one likes an application which is slow to respond to a user input. No one likes an application which is slow to resume, slow to suspend, or slow to a rotation, right? So you want to make sure your application is really snappy, really fast, starts up really quickly, because that is where your experience is. Right? If your application is providing those scrollable and panable content, you want to make sure that content which is moving across the screen is really smooth, has that fluid, buttery smooth experience. Right? You want to provide that fluid, glitch-free, 60 FPS, smooth experience of panning. If you have a media content playing, you want to make sure that the media does not drop frames. You have a great experience of AV sync there. So all those things matters. Right? At the same time, you want to ensure that your application plays along with other applications in the system. Because when you see these devices, which are going smaller and smaller in form factor, the battery life really matters. The efficiency of your application really matters. The way how it uses the resources in your system really matters. Because you don't want your application to be the one which is killed by the PLM, because this is the one which is taking the most amount of memory in the system. You don't want your application to be the top in the task manager when user goes and says, let me go and kill an application which is consuming the most CPU. Right? So you want to make sure when you're building your application, you're building it for fast, fluid, and efficiency. So how do you build that? So basic thing you have to do is you have to build this culture of performance when you're thinking about your application from the day one. Because the basic building blocks of your application define the performance characteristic of your application. Because once the application is built, you cannot really fix the problem. Because what you're doing at that time is you're putting the patches, and these patches are going to come back and haunt you release after release. Because you cannot change the basic infrastructure. You cannot change the architecture of the system which has caused those problems. Right? It goes back to those basic building blocks. And one of the important basic building block of your application is the runtime on which you're taking the dependency. Right? If you're going to write a really critical, time-critical app. Like if you're writing a game, if you are writing an application where getting the pixel to the screen is the most important thing for that application. You want that pixel to the screen as soon as possible, as fast as possible, as efficient as possible. Your choice of runtime is DX, because DX is what is sitting on the lowest level of the system, talking to the hardware directly. So if you're writing an application on top of DX, you are writing to the metal. You will get the most efficiency out of that system. You can get all those fast, fluid, and efficient performance from that application. But the DX has its own limitations. If you're looking for a richer control set, if you're looking for customizing your controls, if you're looking for data binding, if you're looking for those patterns which you want to use in an application, DX does not provide that. Then you have to build those infrastructure on top of it. You have to home grow those infrastructure. That is where the richer platforms like XAML and HTML come into picture. Great platforms, lot of rich features, awesome features. You can use those controls. You can customize those controls. You can have your MVVM patterns on them. Create a really nice experience around that. But one thing which you need to understand is those features which those rich platforms provide you have cost. The reason I'm talking about cost is because now we are not in the world where you have a desktop with tons and tons of cores and tons of power there. You have a limited power of battery. You have limited power of CPU. You have to think in terms of watts. You have to think in terms of CPU cycles, what you're consuming. Right? When we talk about cost, the cost comes with budget. Because if you don't think about budget when you're talking about cost, you are in trouble. Right? So when you talk about cost, there is a budget. So every feature, every scenario, every experience you have in your application has a budget. And when you use this feature, you need to think about this budget in your experience. Take an example, startup. The startup of an application starts from clicking of a tile and showing off a window. The time duration what you have is the time when the process starts to the time when the splash screen dismisses. So your leverage for that budget is a little larger because it's around 730 milliseconds, right? So you have a leverage of using some richer features from the platform. But if you take the same experience on a panning or an animation, you have a very, very small budget there. Why? To get that fluid experience, to get that smooth, buttery, smooth feeling of that animation, to get a nice feeling on your panning, you want to hit that 16.5 millisecond budget. And that 16.5 millisecond is really critical to get that 60 FPS frame rate going. And in that 16.5 millisecond, you start using really, really rich features. Those are going to cost, and these are going to create layers on your system. Talking about feature, I do want to talk about these patterns. Last few years, we have seen a lot of great patterns evolving. MVVM is one of them. Awesome patterns. I love MVVM. It creates a lot of modularity into your application, right? It gives you that power of separating your data from the model. Awesome pattern. But one thing which you need to understand is these patterns are design patterns. They are not implementation detail. Implementation is something which you do in your application. So when you're implementing these patterns, you have to keep your budget in your mind. Because sometimes these patterns may create layers. Because these patterns are really helping you as a developer, we as a developers. These patterns really don't help the end consumer who's using your application. Right? You have to make sure that when you're using these patterns, keep your budget in mind. If your pattern does not going to have that budget, if your pattern is going to create layers for your limited budget of 16.5 milliseconds, then you have to rethink about those patterns. Right? So the key thing which you have to understand is this pattern sometimes may create layers, and those layers can come back and haunt your budget and can create some performance issues. Let's switch from gears here and dive into the architecture of XAML a little bit. From 8.0 to 8.1, we have done some good changes into performance architecture, the XAML architecture. And we have done a lot of performance improvements in the platform too. At very high level, the XAML has a very layered architecture. At lowest level, we use the system-provided all the features. Like we use DX, or we use DComp to draw our primitives. We use DWM to composite our scene. We use MPT to create that awesome media experience. We use direct composition to have an independent input. On top of it, we have our framework layer where create control experience. We have our tree manipulation events. We handle events in that. The whole framework layer has got all the things which you need to create a great experience around your application. On top of the framework layer, we have a very thin layer of APIs which are exposed to language projections, and language projections sit on top of that and provide you a great developer experience for your application. So what does that mean? It means if you're writing a C++ app, if you're writing a C++ XAML app, there is no CLR involved in that. It's completely native. The whole XAML platform is completely native. There's no CLR. If you're writing a C# app, then the CLR comes into picture. XAML platform also take advantage of multiple cores. We are very efficient in taking advantage of cores. We make sure we have threads which can parallelize all the heavy lifting. At very high level, we have two main threads, the UI thread and the render thread. The UI thread is the main heavy lifting thread. This thread is mainly responsible for creating your tree, parsing your tree, applying templates, handling your input, running your user code, and creating the first scene during the startup. The render thread, on the other hand, is running parallel to UI thread and is responsible for running your animations. Or in the other terms, you can say moving the visuals around the scene, which can be independently moved without the help of UI thread. This is important to understand because we will use this reference in our next slides. The UI thread is creating these objects, laying out these objects, and rendering the first scene. The render thread applies transforms to these visuals, to move these visuals across the scene to create an independent animation effect. We have many other threads in the background which also do some heavy lifting, like image decoding or rasterizing text or some asynchronous operations. Another thing to think about is what is happening during the lifetime of a process in the XAML application. The whole activity in the XAML application is broken down into frames. Anything which you see on the screen is a result of a frame. Either it is a UI thread frame or is it a render thread frame. If it's an animation which is running independently, then it's a response of an animating object created on a render thread. The very first frame created on the UI thread is because the UI thread has created those objects, created those visuals, and created the frame. Right? The reason I'm talking about this is because when we go analyze these performance issues, we are going to analyze in terms of frames, because frame is the thing which is creating the scene on the screen. So the very first question which comes into your mind when you're looking into an app or an app which has a performance problem is, hey, my app is slow. That's a very vague question. My app is slow, what do I do? Or my app is slow, please help me. Right? So very first thing which you do is narrow down your problem, because app is slow is a very generic term. Where is it slow? Which experience is slow? That is what is going to guide you towards analyzing your application, figuring out what you need to do, and using these tools. Right? It could be slow in startup. It could be slow in navigation. It could be slow in animation. It could be slow in panning. It could be suspend resume. It could be consuming a lot of resources. So first thing which you need to understand is, what is that experience which is slow, so that you can go and narrow down those things. So let's dive a little bit deeper and talk about each of these experiences and see what could cause those experiences to have a performance problem, and what tools can we use to diagnose those issues, and some guidance which you can help you to not step into those problems. Let's talk about startup. Before I get into the guidance around what should be done to avoid any issues around startup, I do want to give you some background on what is happening in the system when the application starts up. So let's do a little deep dive on this. The experience of startup starts when the user clicks or touches on the tile. As soon as the user touches on the tile, the process starts. As part of the process startup, we create the application object. Remember, all these things are happening in UI thread. The UI thread starts, it creates the application object. And while it creates the application object, it also spins up the render thread, so that render thread can start initializing the DX and the hardware objects. The application object, when it's created, is going to go and load your application.xaml. What does that mean? It means every other XAML which you have referenced in application.xaml is going to be touched and pulled in. That's number one to remember. Once the application object is created and application.xaml is parsed, we fire a loaded event on the application object where the user code runs. Now, there can be a lot of things happening in that user code. Number two, the user code may go and create your gigantic data model. I may use this data model in future, let me go and create it. Okay? All those time are spent in creating your data model. Number three, the user code may say, I want my data to be active and up to the second current. I want to go and connect to cloud and pull everything, synchronous. Spend time on synchronous downloading. Number 3 point. After that, it says, OK, now I have everything I need. Let me go create my main page. So it navigates to main page. Main page object is created. As part of creation of main page object, you're going to load and parse the main page.xaml. In your main page.xaml, you may have references to other XAMLs. You're going to go pull those XAMLs now. In your main page.xaml, you may have references to user controls, custom controls. I'm going to stress on this user control and custom control a little bit now. User controls. As soon as you have a reference of a user control in the XAML, we are going to create that user control. In the constructor of user control, if you go and see, there is a call to load component in a reference to a XAML, the XAML, the UI of that user control. So we are going to load that XAML. So when the user control is touched, the XAML for user control is loaded. Let's talk about custom control now. If you have a reference to custom control, unlike user controls, the custom controls UI is not in its XAML, but it's in its template. So that template is not expanded yet. So during this parsing phase, the user control is created and all the XAML of user control is parsed and objects are created. Whereas for the custom control, only custom control is created. The template is not expanded yet. So now the parsing is happening. So parsing, you created the main page, you parsed the main page has user control was created, its XAML was parsed, it had another user control, and so on. Custom control was there, custom control was created, templates were not applied yet. Once the parsing stage is done, we have this gigantic tree of objects. Then the framework is going to do a layout pass on it. Layout pass has two passes, the measure pass and arrange pass. The measure is when we go and ask each individual element, hey, what's your desired size? When we go through this desired size exercise for each element, the controls whose template has not been expanded yet, they wake up. Oh, I need to know what my desired size is, so I have to expand my template. Or in other terms, I need to apply my template or apply template. Right? So that's what happens. So during the layout pass, during measure, is when the custom control or your controls apply template is called. It goes and loads your generic.xaml, pulls the template out of that, and applies it. So once this exercise is done, the arrange pass is gone through each and every element to make sure that every element is arranged properly on the screen. So once the layout pass is done, we do another pass through the tree to render these elements. So when we're doing a render pass, we actually go and visit each and every element to ask them, okay, now you're ready to render, go create your primitives. The primitives are created, DCOM visuals are created, and pushed down to DWM, and DWM presents your first screen to your monitor. So that's the whole sequence of your startup. And in this startup sequence, if you have any animations, those animations will create the visuals which are targeting those animation or animation which are targeting those visual, and those visuals will be pushed to your render thread. So the render thread can now independently create frames for your animation. So in this whole startup sequence, let's go and analyze this back and see what is the guidance. Well, I don't have to give any guidance because you know what the startup sequence is. You know what could cause your bottleneck here. Right? Let's start from the beginning. Application.xaml. Why to reference all the XAMLs which you really don't need in your startup? Get rid of those. Number two, why to have those gigantic data models which you're not going to use in your startup screen? The key point is this. If you don't see anything in your startup screen, don't create it, because that's going to cause your startup problem. Right? Don't create those things. Delay load your UI. Right? If you have a list view, try to virtualize it, because you don't want those costs of creating all the elements which are not visible in your list view or grid view. Right? If you have tabbed content, interesting thing, if you have a tabbed content, why do you want to create a tab which is not visible? Delay load them. Don't create them during your startup. Right? The number of elements really matters, because as you have learned, the layout pass has got 2 pass and render pass has got 1 pass, complete 3 pass across the tree. More elements, more cost you are going to have in those passes. So try to reduce your element cost as much as possible. I have seen app code where they have used collapsed to collapse the user control with the assumption that, oh, if I collapse the user control, I will not be paying the cost of creating the elements in user control. That's wrong. Why? Because user controls UI is in its XAML and it gets parsed. So even if it is collapsed, you're paying the cost of parsing and creating those objects. If you really want to collapse the custom control, because the templates are not going to take part of a collapse control during the layout. Because the collapse property is for the layout, not for the parser. Yes, because it's a XAML concept, some of them do apply to phone. Some of them. Let me be clarified. Some of them, because the Windows Phone has some characteristics and Windows 8 has some. Windows 8.1 has different characteristics. I can take that offline if you want later. So main thing which I have seen very often is the web request. So I understand that there is a criticality in the application which would need up-to-date data. But you have to think about performance too. Like if you are going to connect to network every time the application is going to start up, that's going to create a really bad experience for the user. because you're waiting on the network. So you have to create some perceived experience to the user which gives a perception that application is fast. So you have to create some custom screen. Right. With that, I do want to switch to my demo to show you how you can use some powerful tools which we internally use to diagnose the problems in your startup or navigation. So WPA comes with two powerful tools, WPR and WPA. So that's a different section which I would highly recommend you should attend, which goes really in depth into these tools, talks about all the different graphs which are available in these tools, and tells you what those graphs do. What I'm going to show you is how you can use this tool to specifically diagnose performance problems in XAML apps. So what we are going to do here is we're going to quickly run WPR. This is the tool which is going to help you capture logs or ETL logs, which you will transfer to a desktop and then view them in WPA. The app which we are going to profile is a very simple app. So I'm going to start the profiling session. I'm going to launch the app. So now I'm tracing the launching of the app. That's the startup sequence of the app. I'm going to profile navigation of the app, which is going to take a really long time to navigate. Why? Because I have a grid view there, and I have a tabbed view, which has got a list view. And then I'm also going to profile a fixed version of this app, which comes up really fast, which again has the same thing, list view and grid view. So once I'm done, I'm going to save the log. And I'm going to switch to my machine, my desktop machine, where I will go and analyze that. So just to save time, what I've done is I've pre-captured a log, the similar log, on my machine. I'm going to open that log in WPA, and I'm going to go over step by step what different graphs mean, and then I'm going to show what graphs are interested for a startup analysis. WPA, when you look at WPA, it looks very confusing because it has got a lot of information. It has a lot of graphs in it. So when you first launch the WPA, it's going to launch with blank. This is how you will see a WPA when it first launches, when you open up any trace. To help developers analyze XAML app, what we have done is we have created a custom profile for XAML apps specifically. The custom profile means a profile where we have selected certain graphs and put into tabs, which will help you and guide you analyze the startup problem or animation problem or planning problem in XAML specific apps. So I'm going to open that profile. So that profile is shipped as part of WPA tool. So when you open that, this is what you will have on the screen. A lot of information and a lot of graphs. But once you understand what these graphs are really showing you, it's very easy to navigate through this graph and navigate through this tremendous amount of data and figure out what and where the problems are happening. So let's look at it. So very first graph, the name itself tells you, the window focused. What it means is it tells you which processes, which window was focused at that particular moment of time. For us, our process was XAML performance demo, and it goes, as soon as I click on that, it goes and selects the region where my performance demo apps window was in foreground and active. The second graph is the GPU or the DWM frame rate. This graph is important if you're analyzing an animation or a panning, because that's where you see what frame rate was the DWM flipping the XAML content into a screen. The third one is where you see the GPU utilization. If you have a lot of content drawn, you want to know why your frames are dropping. Either it's a GPU or a CPU. So this is where it will tell you whether it was GPU driven or was it CPU driven. The third one is going to tell you, so the fourth graph is going to tell you per process how much CPU was consumed. Last one is going to show you a detailed call stack. You can actually go and narrow down your selection in any of this graph range, and you can zoom in, and then you can see the call stack, what was happening during that time duration. If you look at frame analysis, there's another tab, the frame analysis. This is specifically designed to analyze your animation frame rates. Again, the top graph shows how your vsyncs were. If you don't understand what vsync is a simple term given for the synchronization of your monitors. It tells when your DWM is ready to flip the frame to the screen. Right. Second graph is exactly the same as what we saw before. It's a DWM frame rate. Third one is the GPU utilization. These two graphs are an interesting one. So this graph shows what was happening in XAML UI thread and what was happening in XAML render thread, a very high-level breakdown. It will show you how much time was spent in measure, how much time was spent in arrange, how much time was spent in applying template, how much time was spent in parsing, and everything, all the details you will get in here. Next one, again, it's a call stack. You can zoom in and see what was happening in that particular time frame. Last one is a very interesting one. This one shows you a breakdown of each frame. As I mentioned, the whole activity in XAML process is broken down into frames. You can zoom into a particular frame and see how much that frame took. If it was an animation scenario, and if you see that the frame was taking more than 16.5 milliseconds, it very clearly tells you that you're not going to get that smooth animation. So you can zoom into that frame, go into call stack, and see what was happening. So for this demo, what I've done is I have created yet another profile for myself, because all these things are very customizable. You can drag and drop these graphs to any tab you want. You can create a new tab. You can save the profile. You can load the profile. So what I've done is I've created a very simple startup profile, which I'm going to use for this demo. And this startup profile has loaded the ETL log, which we have created, which we saw we created, which has the data for the startup and navigation. So very first thing, let's take a look at how to dive into this tool to analyze the startup problem. The very first thing to understand is what is that you are trying to analyze. You're trying to analyze startup. So what is startup? Startup starts from your process creation and ends when the window was displayed. Right? So those are the two markers. So let's go figure out how to find those two markers first. Very first thing you have to understand to find how to know where the process started. So you have a process lifetime graph here. You have your process here. As soon as you click on that process, the range where the process lifetime or process started and process ended automatically gets selected. So now you know the point when the process was started. Now you need to figure out your endpoint, that is when the window was created or shown. Your first graph shows when the window was started. So basically, if you go and click on XAML performance demo process, it shows you in that graph when the XAML performance demo window was created. So basically, your startup time was between the process start and to the point where the window was created. So let's go back and select our process and take and zoom into the range where our window was created. Let's zoom it. So all the graphs underneath have zoomed to that location. Right? And you can see a summary duration here. So your startup was roughly 1.1 seconds, even though I have a little bit extra time here included. But that's fine. So let's take a look and do a deep dive on what next. What do I have to take a look? So from the sequence of startup, we know that the main thing which is going to cause your startup problem is number of XAMLs which you're going to touch during your startup pass, right? So that's the first thing which you need to figure out, how many XAML did I pull in my startup path. So the region of interest graph is the another one. It will give you a very high-level breakdown of different activities happened in that zoomed view. It talks about all the different threads which were running at that particular time. So what you are interested in is XAML UI thread and XAML render thread. So let's, for this moment, go and select just the XAML UI thread. And if you take a look at the XAML UI thread activities, you will see all the familiar things which we talked about. You have parse, you have layout, you have measure, you have apply template. So you click on anything, it's going to give you the cost of that, how much it was. Right? So let's take a look at the parsing and see what was happening during the parse phase. So if you go and expand this, you will see all the files which you touched during your parsing. So what you have to do now is you have to take down all the XAML files which you touched during your startup phase, go back and review those XAMLs and have a justification why those XAMLs are needed for your startup screen. If they are not needed, redesign your system in such a way that they are delay loaded and they don't cost you during the startup. Right? The other thing which you have to also go and take a look is how many elements are you creating. Right? So there is a generic event graph. This is again a graph which shows you all the events which has happened during that process lifecycle and in that zoomed view. So in this, if you go and filter the selection to XAML, you can see different activities here. In this, there is an event for element create. You can see for that duration, I created 208 elements. That's small, so I'm fine. For this particular case, I'm fine with those kind of elements. So let's keep it like that. So the bottom line is these tools, they seem very confusing, but once you understand what these graphs are really showing you, it's very easy to swim through this tremendous amount of data and find out where your bottlenecks are. Let's take another example of navigation. What did we do to start the navigation? The starting point of the navigation was touching the list view item. So you touched the list view item, it navigated to the new page. Then you touched the back button, it navigated back. Those were the 2 points, right? So let's take a look where those points are. You have a generic touch event here. You have so many touch events happened in the system when we collected these traces. The key thing to understand is you're looking for the touch event which happened immediately after your window was visible, because that was the first thing which you did. So if your window was visible here, and after this point, this was a touch event which you touched. And this touch event corresponds to the touch which you touched the list view item. So from here to here is what your section was for your navigation and coming back. Right? Your navigation cost, now again it goes back to the frames. Your navigation cost was from the point where you touch the list view item to the point where that frame ended. This is where the new graph I'm going to introduce you to. The frame detail, that's this one. This was the graph which we said shows you what was happening in each frame. So you see the big red frame, that was the largest frame which you see, was the frame which was doing your heavy lifting for navigation. So basically your navigation cost was from the point when you touched the screen to the point when this navigation ended. Right? So if you want, you can select this region, because this is what you are interested in, and zoom in. Let's go and repeat the same exercise what we did with the startup. For the navigation, let's go see how many XAML files we parsed. The very first thing what I see here is I have 2 XAMLs, the main XAMLs. I have a grid view XAML and I have a list view XAML. But when I navigated to that page, I had only grid view visible. I had to touch the list view to go to list view. Then why am I paying the cost for the list view there? That's a good question. So I have to go back to my code to ensure that when I'm navigating, I reduce that cost. So that was number 1. So number 2, let me go back, the same thing what I did with the startup, and look at what was my element cost there. $2,190 elements. That clearly shows me that I'm not virtualized. So I have to go back to my app and change my panels to virtualization, to use the virtualization. So these are the tools which we can really use and diagnose your performance problem. The steps are very clear. You need to understand what is that you are focusing on. Right? That's number 1. Number 2, high-level overview of what is happening in the XAML stack. And if you can't find anything there, then you do a deep dive into the stacks, which is also available here. So let me go back to my slides now. Let's talk a little bit of animation and panning. XAML supports two kinds of animations: dependent animation and independent animation. Dependent animations are animations which heavily depend on UI thread. The UI thread is doing the heavy lifting of animation. What that means? It means if an animation needs updates into your layout, then the UI thread has to do the work, because render thread doesn't know how to move those elements, because it needs work in the UI thread to change the layout. Number two, if app code is listening to timer events and driving the animation, it is the app code on every timer event moving these objects around. Independent animations are the animations which are completely independent of UI thread and running on your render thread, where the render thread is actually applying the transforms to your visual objects and moving those visual objects. Right? So it's very clear that if you have a dependent animation, it's going to slow down your animation frame rate. Why? Because UI thread is responsible for way more than just running your animation engine. So ensure that all your animations which you're going to create are independent and not dependent. If you have an independent animation, you have to make sure one more thing, that your GPU overdraw is less. So what is GPU overdraw? So GPU overdraw is where GPU is trying to draw the same pixel multiple times. Imagine you have a full screen canvas with a red background on it, and then you have a small rectangle on top of it, which also happen to have red background or a green background. So when the compositor is compositing this scene, it has to composite the pixel which is inside the rectangle twice, and that is what is called as overdraw. You're overdrawing that pixel 2 times where it's visible only once. Right? So you want to ensure that you reduce your overdraw in your scene as much as possible. Now it goes back to the question, okay, I will reduce the overdraw in my scene, but how do I know that I'm overdrawing? Great question. So in 8.1, we have introduced one additional API than what we had in 8.0. We have 3 APIs now to diagnose your animation problems. Your GPU overdraw, your enable frame rate, and you have dirty regions. So when you use enable frame rate, just like in 8.0, we have frame rate counters on the top, which will show you what your UI thread was running at and what your compositor was running at or your render thread was running at. If you use overdraw heat map, it tells you with a tint of red what portion of your scene was overdrawn. The more darker the red is, more layers of overdraw you have. I'll show you a demo of that pretty soon. The last one is enable redraw region. So what is this? Imagine you have an animation in your startup screen. It's like a splash screen animation. And then that splash screen animation very smoothly transitions to your main page. And you forget to close that animation or collapse that. So what is happening? You have your main page, which is visible to screen, and your user is enjoying that main page, but behind the scene, your animation is running, which is not visible. So that app is a reader app, which is doing nothing, but CPU is churning and your battery is draining. So how do you go and figure out what is happening? That is where your enable redraw region is going to help you. Because by turning on the enable redraw region, we are going to show you what part of the scene was redrawn. And if the animation was running behind the scene, we will show you that animation is running. It will show you in the visual artifact that there was something changing in the scene. So before jumping into the demo of animation, I want to cover panning too, because panning and animation, they go hand in hand. If you have a scrollable or pannable content in your app, the panning is the most experienced scenario or experience you can provide to your app authors. You want to make sure your panning is jitter-free, your panning is smooth, right? So normally we see 2 kinds of problem in panning. Panning is a very interesting subject, and it's a little complicated and goes a little deep dive into the system. So please bear with me. So 2 kinds of problem which we see in panning. Number 1, you touch and you try to pan. The content which is moving is not moving smoothly. It's dropping frames. It's jittery. It doesn't have that buttery smooth feeling, right? So that's a problem number 1. Problem number 2, when this content is moving across the scene, the new content which is getting realized or which is coming in is not able to keep up with the speed at which the content is moving out. So artifact is you see blacks, you see blanks, you don't see the content, you feel like things are slow, it is not to the point what I really want. So these are the 2 different problems you normally see in your panning. The solutions are different and the basic problem behind these are different. So let's go through that. So what is happening? So there are 3 main threads taking part when the panning is happening. You have the UI thread, you have the render thread, and you have a new thread called input thread. Let's keep the input thread aside for now. Let's talk about UI thread and render thread, what it does. So imagine your rectangle, the scene which is visible on your screen. It's like a rectangle. You touch that rectangle, and you move. The moving of this rectangle is responsibility of your render thread. Your render thread is actually putting the transforms into your visual and moving this rectangle slowly at the pace of your finger. When this rectangle is moving, you can imagine there are blacks because it is moving out of your viewport. The UI thread is trying to do its best to make sure those blacks are filled with the new content. Now, there are two cases here. If your panel is virtualized and if your panel is not virtualized. If your panel is not virtualized, you don't have a problem. Why? Everything is realized. You have a gigantic rectangle which your render thread is trying to move. You have no blacks. But you're going to pay the cost in startup because you're creating gigantic amount of elements there. So we highly recommend that don't do that. Use virtualization. Now the question is, if I use virtualization and when this rectangle is moving, how fast can UI thread keep up with this? Great question. So platform doesn't have optimization there. What we do is, instead of just keeping screen worth of data, we keep caches on both sides of the screen. So instead of having this rectangle, you have this rectangle now. So now let's go through this again. You have rectangle, which has caches on both sides. You touch the screen and move this rectangle. This rectangle is moving. When this rectangle is moving, on right side, the UI thread has to put the contents. Let's walk through what happens during putting the contents. For putting the contents, the UI thread has to go create those visuals. The visual tree has to be created. It has to apply the data on top of the root so that the data context can propagate down the root. When the data context propagates down, it has to go and apply those data to individual data elements in your data template. And data template may have data binding, so the framework has to go evaluate that data binding. As part of evaluation of data binding, it calls back to your model and pulls the data down and then sets that data to your view. Let's walk again. You have this rectangle moving. UI thread is trying to create this or fill these containers with your data. While this rectangle is moving, you know what is happening this side. What is happening this side? The items are coming out of your cache, right? So framework does another optimization. It says, why should I recreate these things? I can reuse these things. So when you move this rectangle, things which are falling off are reused and plugged in here. So we recycle the containers. One thing to keep in mind. Framework tries to recycle the containers if the data type is same. If your data template has got 3 text blocks, 2 images across the board, it's very easy to recycle the containers because nothing is changing. But if you have variable data types, platform tries to make sure that for certain number of data templates, variable data templates, we try to recycle. But at some point we say, we give up. We can't recycle this. We're going to recreate everything. So that's number 4 we have to understand. Variable data templates. Right? Keep these things in mind because I'm going to reference this back when we talk about the guidance. So when this rectangle is moving, all the new spots are filled by recycled items. That is number 1. Number 2 cost, data is applied on the root, data context is propagated. Number 2nd cost. Number 3rd, the data binding on your data template is evaluated. Goes back to your model, pulls the data, and applies. Let's walk this through again and talk about this in context of input thread now. The whole sequence starts with you touching the finger. You touch the finger on the screen. The input is routed across your tree. The scroll viewer sitting there says, yep, I understand this input. Let me go create the viewport. It creates the viewport. It goes also asks the direct manipulation engine to start an independent input thread. What is direct manipulation? So direct manipulation is an engine which has a complex algorithm to understand your gestures. Because when you're using a touch, you can use many gestures. You can have a pinch gesture, zoom gesture, flick gesture, pan gesture. Right? So you need a different engine which understands this gesture, which can convert this input messages to different gestures. So from here on, the input thread is getting the input independently. Your UI thread is pulling the input thread to get the new coordinates which it can apply to scroll viewer, so the scroll viewer can recycle the containers and apply the data context and data binding. The render thread is polling the input thread, asking for new transforms based on the gestures so that it can apply those transforms to this rectangle. It can be pinch or zoom, it can be pan, it can be flick. So with these things, let's now walk back and see what guidance will we have to improve your panning. Very simple. If you're seeing your rectangle is not moving with the pace what you really want, right? What is happening? Your render thread is not able to keep up. GPU overdraw is your problem. So try to avoid the GPU overdraw there also. If your responsiveness is a problem, or if your content is not able to realize the speed at which the content is moving, you have a couple of things you have to take care of. Number one, how many different types of templates are you using? Variable data templates. If you have a single type of data template, or if you have single type of data, then you should not have any problem. That's number one. Number two, how deep is your data template? Do you have nested data templates? Because deeper the data template, more time you're going to have walk that tree to propagate the data and data context. Number four, your binding. How many bindings do you have? Because more the bindings you're going to have in that, more time the platform is going to spend evaluating that binding, because we have to evaluate those properties, all those nested properties, before we can call back to the model to get the actual data. Right? Let's say you do all those things, and you still don't have a performance. What do we do? For 8.1, if we have introduced an API which is going to give you the power to the metal. What this means is, using this API, you are in the control seat now. You know that you have the complete control, and you know what those data templates are, what that tree for each individual list view item looks like, and you are saying, platform, don't do anything. I'm going to take the control. I'm going to set those data directly. So what this API is going to do is, the API name itself specifies the container content changing. So when this container is getting recycled, when the content of this has to be changed, we call back to the user code and says, user or app, you take care of it. Platform is not going to do anything for you. We have this container ready for you. There are tree or elements in this. Here is the data. Do what you want. So by using this API, you're like bypassing everything from the platform. You have the power of setting everything. You don't pay the cost of data binding at all. On top of it, you also have an advantage of creating a phased approach. If you see that you're still not getting performance, and your tree is really expensive for each of these items, and you want to have a perceived experience of panning, what it means is, when you're really panning, the final UI of those individual list view items are going to be phased in multiple phases. In each phase, you can control what is shown on the screen. If you have 5 text blocks and 3 images, you can make a call that images are something which I can delay. I don't want right now. When you're really panning fast, your budget is 16.5 milliseconds. Let me go and see what I can do in that. Right? So this is API which you want to use. There's another talk. Chapalo is giving another talk which goes deep dive into this specific API and to use how to create the perceived experience around incremental loading. So let me quickly jump into the demo part of this to show how you can analyze an animation and panning. We are back to WPA. So what I have here is a very simple profile to analyze the animation. Going back to our rule, when we look for animation, or a scenario which we are profiling is animation. So what is that we are looking for? We're looking for the frame which took longer than 16.5 milliseconds. Right? So that is what we are looking for. So this graph is, there are multiple graphs here which is going to help you analyze the animation problem. So before driving into or drilling into this, these graphs, let's go take a look at the application which we want to profile. Right? So we'll go back to our application here. So very first thing which I want to show you is the usage of those debug setting flags and how they look like. The first one is a dependent animation of text. So here the animation is created using the layout properties of text block. The text block's width and height property is animated, and that animation is running on UI thread because the width and height property needs a layout update. What I have done just now is I just call the debug setting enable frame rate to true, which brings me the frame rates on the top of my screen, which tells me what my UI thread was running at and what my render thread was running at. On my right side of the screen is a render thread, and on my left side of the screen is where the UI thread is. Same thing if I do on the animation, which is completely independent, which you can see is really smooth. And you can see how the UI thread and render threads are performing on that. Right. It's the same debug setting. Let's go and look at the second debug setting. Sorry. So what that showed was that showed animating splash screen, and then the UI came on top of it. In this UI, there's nothing happening on the screen, but the CPU is churning. So how do you know that CPU is churning? It's very simple. You don't have to go to WPA to get that. You just turn on the redraw region. You can see that the animation which is running behind the scene is now visible. So any update on the scene can be very easily seen. Like I'm touching the screen, you can see the artifact of the visual artifacts there. That shows that something was changing in the screen, and that helps you to know what is changing. Let's take a look at overdraw now. So this is an app where I have a lot of overdraws in the scene. So if you turn on the overdraw heap map, you can see the tint of red getting really dark at certain places. Those are the places where you really have a lot of overdraws. And the same app, after fixing the overdraw, it looks much better, because now I don't have those overdraws. The things which I had overdraw in my previous one, I had a background with the same color, and I had another border with the same color. On top of it, I had images, and on top of it, I had a rectangle with the same color. So I had a lot of overdraws there. Let's take a look at panning. In Windows 8, this is the default experience we had. If you really try to pan fast, you can see the content is not able to keep up. I'm panning, and there's nothing on the screen. Right? In Windows 8.1, we have turned on the placeholders by default. So you don't have to do anything. You don't have to call any API. You just recompile to 8.1, and you get a much better perceived experience out of that, because placeholders are taking place instead of the black screen. It gives a much better perceived experience. Right? And the same app using much richer API around container content changing. Right? With that, if you see, I'm not going to see any placeholders, or some placeholders, or the placeholders which you are going to see are the incremental placeholders, the placeholders which were controlled by the app code. You can see how the image is getting delayed and the text is showing first. So these are the phases. The first phase, the text is coming up. Second phase, the image is coming up. And third phase, the entire content is coming up. So you can control the experience what you really need with these APIs. So let's switch back to my WPA slide there. So what I have here now is a log which I collected for my animation. The first animation where we were seeing the frames were not keeping up, or the text was really jittery or dropping frames. So when you're looking at the animation, or when you are analyzing the animation, the key thing to understand is to deep dive into the frame. So you can see here, my GPU is still low. So that means I'm not really stressing the GPU, but still I'm dropping frames. My CPU is very high. My render thread is doing nothing. So this is the portion which is problematic. So I will just zoom into this area, and I can very clearly see I'm doing a measure and I'm doing an arrange. So I'm doing a layout pass in every frame. So let's go take a look at the frame analysis. So you can see here frame. Each color is a different frame. So we can just select one of the frames here. And then drill into it, and you will see in this frame, it's basically doing a layout pass. And you can see the layout pass is happening on the text block. So by this, you can very clearly see the 100% CPU which was utilized in UI thread was because you are running a lot of layout pass on a text block on every frame. So you go back to your code and see why you are doing that. You change that width and height animation of the text block to the transform or the scale transform animation for the text block, and you will fix the animation problem. You're moving the animation problem from dependent animation to independent animation. Right. The same thing, let's take a look at the panning problem here. I took a panning log. This was, again, first I took the log for the panning experience where we were seeing blacks or blank in the screen. So as we know from the explanation of panning, if you see blacks on the screen, it's because your UI thread is not able to realize the item quickly. What that means is the frame or the UI thread frame is really, really large. It's larger than 16.5 milliseconds. So that, and that's because of that, it's not able to keep up with the compositors moving of rectangle. So again, if you go and look at these frames, you zoom into the frame, and you can go and select one of the frames here, or zoom into this one of the frames. And see what is happening in this one. It's again running the layout pass, and there's a grid, and there's an apply template on that. So you can see the apply template, which is happening during the panning phase, is causing those additional cost of the realization of items. Because in my code, I had multiple different templates applied for that data. So what you want to avoid here is when the containers are getting recycled, you want to ensure that those containers can be recycled and reuse the templates which were there for it. Going back to my slides. I want to talk about media a little bit. So if you have a media content in your application, the best experience what you can provide by media is to provide a glitch-free media playback experience. So the best media experience you can provide is by having a full screen media. Because when you are in full screen, the XAML platform ensures that you are directly talking to the media platform, the lowest possible layer in the system. So we have a new API in 8.1 which will make sure that you are pixel perfect in full screen, and you don't have to worry about calculating your size of the screen and stretching your media to that screen. If you use media element.is full window, will automatically stretch your window or automatically stretch your media to the full screen. If you have overlaid content on the media, make sure that overlaid content are short-lived, because as soon as you have an overlaid content on the full screen media, we are going to get out of deflip. What is deflip? Deflip is the optimized way of DWM flipping the screen scenes into a screen. This is where you will get the most performant experience, most performant battery consumption. So if you have overlaid content on the media, make sure to bring those contents down as soon as your activity is done. If you have a media content, use poster source. What is poster source? If you're using a media element, we as a platform, we assume that you're going to play the media playback. So we are going to create all the resources needed to play back that media. If you have this media element in your grid view for each of your grid view items, you don't want to pay the cost of all those things. So you want to ensure that those costs are delayed until those media is really used. So if you use a poster source, you will not pay that cost. Right. Same thing with memory. This comes back to the efficiency of your system, how efficiently you're using the system resources. So you want to make sure that you have smaller tree, virtualized content, delay loading the content. Your element count should not be too high. And when you're decoding those images, you decode those images to the size which you really want. Right? So with that, I do want to share some of the improvements which we made when compared to Windows 8. We have done and invested a lot of time, a lot of effort in optimizing our platform. We have a full support of binary XAML. Our startup is faster. We have seen a startup improvement all the way up to 20 to 25%. We have a full support of binary XAML. Using binary XAML, you can get up to 25% startup speed. Our grouping performance, if you have a grouped grid view and you have panning, those grouping performance is twice the fast it was in 8.0. We have new APIs which will help you create those incremental experience in your panning. Right? Our media playback has a better integration with our media platform. Our graphics has a better integration with our decomp and D3D. That's going to improve your performance. Right? So what I'm trying to say here is the great experience of the app is provided by the performant platform and performant app. So it's the app and the platform together has to create this performant experience for our end users. Right? So we are, as a platform owners, we are going to continue to improve our platform in future releases. At the same time, what I'm asking is, as an app developers, we have to ensure that we build those app performance. With that, I really want to thank you all for listening to me and coming to this talk, and enjoy your rest of the session. Thank you.